Hello, everyone. We're matching moms to mentors with machine learning, and we worked with the nonprofit organization Nurture PA. Mothers are assigned a needs risk level and are paired up with a mentor of varying capabilities according to that level. So we want to find a way to identify whether a mother is a high or low needs risk, and we want to figure out the appropriate type of way to match them with the mentors.
So the approach that we took for this project, we started off with data exploration in Excel, just trying to understand what were the underlying relationships in the data set. Then we moved into model development in Python. So we were doing data cleaning, feature engineering, testing a couple different algorithms. Once we decided on one, we were tuning parameters and validating that final model. And then we moved into the model deployment phase where we took an object-oriented programming approach in Python to create production code scripts. We also visualized the model's performance and predictions in Tableau. At the bottom left here, you can see a screenshot of one of the plots from that Tableau dashboard, just showing how that needs risk level varies depending on income group of the mother.
So in terms of how we selected an algorithm, we tried multiple different classification algorithms across a few different scoring metrics as well. So accuracy is just what percentage do we correctly classify out of all the moms. Recall is out of the high risk moms, what percent do we get correct? And that's really something we wanted to focus on. So we developed the NPA metric where we're weighting that more heavily. And you can see the results across these metrics for each model in the table below. We ended up selecting logistic regression because it had the highest NPA metric score. So in terms of the model itself, a logistic regression model is essentially just weighting the features by some sort of a coefficient to capture a relationship within the data. And specifically with logistic regression, that output will be between 0 and 1. And you can think of it like a probability. So for our feature coefficients, you can see in the plot below, each of those are graphed, and a higher weight, for example, 1.13 there, is going to increase a high needs risk probability of a mother.
For the scripts and implementation, once a variable is put into the website, the predictor script takes that and reformats the input and determines which model or submodel to use from the model file container, and it generates a prediction sending this back to the website. For the update model script, first the tech expert uploads a new data file, and this script first reformats the data and retrains the model while maximizing the NPA metric and outputs the updated model to the model file container. We created an instructional document that provides detailed descriptions of all files and necessary steps for the tech expert to update these files and keep the models running. And we also created a Tableau dashboard that's an interactive representation of both the model and the different data that we had. For the impact, Nurture PA in the short term is no longer relying on Allegheny County to provide these classifications, so they're now independent because of this model. And in the long term, Nurture PA can reach about 400 more moms beyond Allegheny, giving them the care and support that they need.